Hello everybody and welcome. In today's video we're going to be covering determinants of square matrices and we're going to be going over a few examples. And just a note, it's going to be a little bit heavier on the lecture side, especially when we get to the 3x3 matrices, just because there's so much stuff to discuss. But other than that, we're going to try to keep it as simple as we can and go over some examples. So without further ado, let's get it. Alright, so let's first start by going over determinants of 2x2 matrices. It's a lot more simple than the 3x3s, but anyway, let's look at this formula here. What it's saying is that the determinant of A, which is also written like this with like those absolute value signs, that's just a shorthand way of writing the determinant, is equal to just some matrix. So these right here, A1, A2, B1, and B2 are just numbers. The determinant is equal to A1, B2 minus A2, B1. And all that is by taking these diagonals here, so that's A1, B2, that is underlined in blue, and we subtract that by the other diagonal right over here. Okay, so you take the numbers that are circled in blue, you multiply those, and you subtract it by the numbers that are circled in red. All right, so with that being said, let's go over a couple examples here. And I'm just going to go ahead and label this matrix A. It can be any letter you want. So what we do is we draw a diagonal like that. So those are that's our first set of numbers. So we multiply those, 2 times 2. And now that is going to be subtracted by the other numbers in the other diagonal here in red. So 1 times -3. Okay, so our determinant of A is going to be equal to that there, like that. All right, so let's go ahead and continue. Determinant of A is equal to 4. -3 is on the inside there with this other negative sign, so that's going to become a positive 3. Therefore, our determinant of this matrix is equal to 7, like that. Okay, so that's how you find the determinant. Now let's go ahead and do the second example here. So I'm going to call this matrix B. All right, so first let's circle our first diagonal numbers right here. And that is going to give us the determinant of B is equal to 2 times 2 subtracted by the other numbers in the diagonal here, which is 4 times 1. All right, so the determinant of B is equal to 4 minus 4. And when you simplify that, your determinant is 0. All right, so determinant can be positive, negative, it can be 0. Whenever it's 0, though, we should note that this has no inverse. And basically, that just means that the matrix is singular. All right, so that's just a side note there, but this is your answer to that example there. Therefore, we covered determinants of 2x2 matrices. Now, let's go on to the more complicated ones, the 3x3s. All right, so now let's look at determinants of a 3x3 matrix. This can also apply to greater orders, but we're going to keep it a little bit more simple and go with 3x3s. So let's look at a couple definitions first. A minor, which is pretty much the determinant of a matrix obtained by deleting the ith row and jth column. This is pretty much where the majority of the work is going to be coming from. We're going to be finding the minors um, of our matrices. All right. The second one is the cofactor. This right here here's the definition to the right of it. However, the only thing you really need to know is the cofactor is going to determine the sign of the minor, whether it's going to be positive or negative, whether you change the sign or you keep it the same. All right. So the cofactor, the definition is given right here, underlined in red, right there. And all this is saying is that the cofactor of a certain entry, so I is equal to row, the row number, and j is equal to the column number, is -1 raised to the I plus j. So if it was, for example, row 3, column 2, you would put a 3 plus 2 in those parentheses, times the minor, right here, of that same corresponding entry. Okay, so that's the definition there. And there's a simple trick that you can use, which I show here on the right, called the cofactor matrix right here. And this is going to tell us whether what sign we need to multiply it to. So if we're looking at this, we can see that it alternates from positive to positive to negative, so on and so forth. All right. So whenever we expand and we find a minor, so for example, let's just say we find the minor for this entry here whenever we see our matrix. All that's saying is that that minor, we have to multiply it by that sign, whether it's positive or negative, and then that's how you get your cofactor. Okay, so the cofactor is just one of these signs multiplied to the minor. All right. So after we find our cofactors, the determinant is going to be equal to um, the entry of that matrix times the cofactor of that matrix. And these numbers can change. It doesn't always have to be row 1, column 1. It all depends on the row or column that we expand from. Okay, so this is just a brief, overview of like some of the terms and stuff like that. Let's go over some examples just to kind of clear this up because I'm sure it's confusing at this point. So let's begin working through some examples. All right, so we have this 3 by 3 matrix here, and we want to expand by cofactors to find the determinant. So the first step that we want to do here is determine which row or column to expand by. Okay, so to figure out which one you want to expand by is you basically look at all the numbers that you have here and you look at all the rows and columns and you want to figure out, okay, which one has the most zeros or the lowest numbers, and that's the one that you want to expand by. So when I'm looking at this matrix, I'm going to expand by row 1 here. All right, we see that there's a 0, there's a 2 and a 1. Those numbers are low. The zero's there. Perfect. All right, so that's the one I'm going to expand by. So step number 1, we found out that we want to expand by row 1. Step number 2 is we want to set up our new matrices. And these matrices are to find the minor, and then after that we find the cofactor of each of those. So let's set up our matrices. And the way we do that is we're going to write that the minor of 0, because that's our first entry. So the minor of row 1, column 1, right here, we're looking at this 0. And the new matrix that we get when we do this is obtained by deleting the row that that number is in, that 0, and the column that that number is in. And then you write down all the numbers that remain, which is -1, 2, 0, and 1. Okay, so that is going to be the minor of that 0 that we picked in row 1, column 1. Now, let's look at the minor of row 1, column 2. And again, we're always picking row 1 because that is where we are expanding. That's what we're expanding by. So now we're looking at this number here, this 2. So what we want to do is delete the row and the column that that number is in, and we can obtain our matrix by writing in all the numbers that remain, which is 3, 2, 4, and 1. All right, now let's find our third matrix here. The minor of row 1, column 3 is equal to, looking back at our original matrix, now we circle the 1 there, the last number in our row that we're expanding by. You delete the row and the column that that number is in, and you write down the remaining numbers that are left over, which is 3, -1, 4, and 0. All right, so now what we got to do is basically find the determinants of each of these three matrices. Okay, so the determinants of these matrices is called our minor. All right, so let's go ahead and start. And if you don't remember how to find the determinant, it's quite simple. All you do is you circle your first diagonal and you multiply those numbers together. So -1 times 1 is going to be equal to, oh, sorry, -1 times 1 subtracted by the other two numbers the other two numbers in the other diagonal multiplied by each other. So that is 2 and 0, like that. So that's how you find your determinant or your minor for that matrix. So what we have here is -1 times 1 is -1 minus 2 times 0, which is 0. So we have -1. All right, so let's continue on here. This one is going to be 3 times 1 minus 4 times 2, which is equal to 3 minus 8, -5. Okay, so the last one here, we have 3 times 0 minus -1 times 4, which is going to be equal to +4, just like that. All right, now we have our minors. What we can do is find our cofactors. So our cofactors, C1, 1, C1, 2, and C1, 3, is equal to our minor, which we found out for this one, for the top one, is -1, times, we want to figure out what sign I need to multiply this -1 by. Okay, I'm going to show the cofactor matrix on the screen right now. So when you're looking at this, you can see that row 1, column 1, there is a positive sign there. Okay, so that means that in this parenthesis, we're going to write a positive sign. So our cofactor becomes C11 is equal to a positive times a negative is still a negative. So our sign doesn't change for this one. So that right there is our first cofactor. All right, now let's look at the second cofactor. So row 1, column 2. So our cofactor is -5, which is our minor, times, I'm going to pull up the cofactor matrix again. We're looking at row 1, column 2, which is a negative. So I'm going to go ahead and put a negative sign in that parenthesis. Therefore, my cofactor is equal to -5 times a negative number is going to be +5. All right. Now let's look at the third one. Our minor is 4, and I'm going to pull up the cofactor matrix again. We're looking at row 1, column 3. That sign is a positive, so I'm going to go ahead and put a positive sign in that parenthesis there. And then we find out that our cofactor is equal to +5. 4. All right, so we found our minors and we found our cofactors. So we are now at step 4. So let's go ahead to the next page and finish this off. Continuing on here. So we found all of our cofactors. Now, step 4 is to multiply the cofactors by the corresponding entry. Okay, so let's look at this first one here, C11. So that 1, 1 represents the entry in the first row and first column. So that entry is 0. And we have to multiply that by our cofactor, which is -1. And that is going to equal to 0. All right, now let's look at the second one right here, C12. So the corresponding entry is row 1, column 2, which is this 2 right here. So that is going to give us 2 times 5. And that is going to equal to 10. All right, last one here. We have row 1, column 3, which is this entry here. So that is going to be 1 times 4, which is our cofactor there. Okay, so we just finished step 4, multiplying all the cofactors by the corresponding entries. Now all we have to do is add all of those numbers up that we just found. Okay, so 0 plus 10 plus 4 is equal to 14, and that is our determinant. So, one thing I should note is that one of the reasons why we expand by a row or a column that has a 0 is so that you can eliminate some steps. Okay, we could have eliminated the entire process of finding uh, the cofactor for that entry, the 0 entry, because that's the reason why you expand by it. You know it's going to be a 0. However, you might come across examples where there are no zeros. So I wanted to show the full example. Um, that way, when you run into a problem where there is no zeros, then this is going to be the full process that you're going to have to go through, and you're going to have 3 matrices and 3 cofactors. So you're going to have to do it this way. All right. So I know it's a long example, but it takes a while to do these problems. So we finished all these. We did all the steps. We found our determinant. Therefore, this example is complete.